Hey there, science fans! Today, we're diving into the fascinating world of significant figures. Imagine you're baking a cake. You wouldn't just throw in a handful of flour, right? You'd carefully measure each ingredient to get that perfect texture and taste. Well, in the world of science and engineering, precision is just as critical. That's where significant figures come in. They tell us how reliable and accurate a measurement is. Think of them as the secret code to understanding the precision of a number. Whether you're measuring the speed of light or the width of a human hair, significant figures help us communicate and interpret data with clarity and confidence. They're the unsung heroes of scientific accuracy, ensuring that our experiments and calculations are based on solid ground. So buckle up as we embark on this exciting journey to unlock the power of significant figures. Now, how do we crack the code of significant figures? It's like solving a puzzle where every piece counts. It's all about identifying the digits that truly matter in a measurement. These digits are crucial because they tell us the precision of our measurements. Let's break it down with some simple rules that will make it easier to understand and apply in real-life scenarios. Rule 1. Any non-zero digit is always significant. This means every digit from 1 to 9 counts. For example, in the number 23.5, all three digits, 2, 3, and 5, are significant. Each of these digits contributes to the accuracy of the measurement. Rule 2. Zeros between non-zero digits are significant. These zeros are like bridges connecting the significant digits. Take 105, for instance. The zero sandwiched between 1 and 5 is significant, making all three digits count. This rule helps us maintain the integrity of the measurement. Rule 3. Leading zeros. Zeros to the left of the first non-zero digit are never significant. They're just placeholders. They don't add any precision to the measurement. So, in 0.052, only the digits 5 and 2 are significant. The leading zeros are just there to position the decimal point correctly. Rule 4. Trailing zeros, zeros to the right of the last non-zero digit, are significant only if there's a decimal point present. These zeros indicate the precision of the measurement. For example, 25.00 has 4 significant figures because the decimal point tells us those zeros matter. This shows a higher level of precision. By mastering these rules, you'll become a pro at determining the number of significant figures in any measurement. This skill is essential for anyone working in science, engineering, or any field that relies on precise measurements. Hold on tight because things are about to get interesting. When we perform calculations with measurements, we need to make sure our answers reflect the precision of the original data. That's where significant figure rules for calculations come into play. There are different rules for multiplication and division than for addition and subtraction. Don't worry though, it's like learning a new dance move. It might seem tricky at first, but with a little practice, you'll be gliding across the dance floor of significant figures in no time. So let's put on our dancing shoes and learn the steps to calculating with confidence while keeping those significant figures in check. In the realm of multiplication and division, the rule is simple. The answer should have the same number of significant figures as the measurement with the fewest significant figures. Let's illustrate this with an example. Say you're calculating the area of a rectangle with sides measuring 4.2 centimeters and 6.85 centimeters. Multiplying those values gives you 28.97 square centimeters. However, since 4.2 centimeters has only 2 significant figures, the fewest in our calculation, we need to round our answer to 2 significant figures. Therefore, the final answer is 29 square centimeters. Remember, when multiplying or dividing, it's all about matching the precision of the least precise measurement. Section 5. Addition and subtraction aligning decimal places. Addition and subtraction follow a slightly different rhythm. Here we focus on decimal places rather than the total number of significant figures. The rule is this. The answer should have the same number of decimal places as the measurement with the fewest decimal places. Let's imagine you're adding the masses of two objects, 12.34 grams and 5.6 grams. The sum is 17.94 grams. However, since 5.6 grams has only one decimal place, which is the fewest in this case, we need to round our answer to one decimal place. Thus, the final answer is 18.0 grams. Remember, when adding or subtracting, it's all about aligning those decimal places. Section 6. Scientific notation, handling extremely large and small numbers. Now let's venture into the realm of the very large and the very small. Imagine traveling from the vast expanses of the universe where distances are measured in light years to the tiny world of atoms and molecules where measurements are in nanometers. When dealing with astronomical distances or microscopic particles, we often encounter numbers that are incredibly long and cumbersome to write out. These numbers can be so large or so small that they become difficult to comprehend and work with in their standard form. That's where scientific notation swoops in to save the day. This powerful tool allows us to express these unwieldy numbers in a much more compact and manageable form. Scientific notation expresses a number as a product of a coefficient and 10 raised to a power. This method not only simplifies the numbers, but also makes calculations easier and more accurate. The coefficient is always a number between 1 and 10, and the exponent indicates the number of places the decimal point is moved. This way, we can easily convert any large or small number into a more digestible format. For instance, the speed of light, approximately 299,792,458 meters per second, can be expressed in scientific notation as 2.9979245 times 10 to the power of 8 meters per second. This not only makes the number shorter but also easier to read and understand, much more manageable, right? By using scientific notation, we can handle these extreme values with ease and precision. Scientific notation not only simplifies our lives but also helps us maintain the correct number of significant figures when dealing with extremely large or small numbers. It's a win-win situation. Whether you're an astronomer measuring the distance between stars or a chemist calculating the size of molecules, scientific notation is an indispensable tool in your toolkit. Section 7. Practical applications, from instruments to engineering. Significant figures aren't just theoretical concepts confined to textbooks. They have real-world implications in countless fields, from scientific research to engineering marvels. Imagine you're a scientist measuring the volume of a liquid using a graduated cylinder. The precision of your measurement depends on the markings on the cylinder. If the smallest markings represent 0.1 milliliters, you can only estimate the volume to the nearest tenth of a milliliter. Similarly, in engineering, significant figures are crucial for ensuring the accuracy and reliability of designs and calculations. Whether you're building a bridge or designing a microchip, every measurement must be made and reported with the appropriate number of significant figures to avoid potentially disastrous consequences. Section 8. Avoiding pitfalls, common errors and how to avoid them. Even the most seasoned scientists and engineers can fall prey to common pitfalls when it comes to significant figures. One frequent error is rounding numbers too early in a calculation. Always carry extra digits throughout your calculations and round only the final answer to the correct number of significant figures. Another common mistake is misinterpreting the significance of zeros. Remember, leading zeros are never significant, while trailing zeros are significant only if a decimal point is present. By being mindful of these common errors and following the rules diligently, you can navigate the world of significant figures with confidence and precision. Section 9. The Quest for Accuracy, a historical perspective on significant figures. The concept of significant figures has evolved over centuries, as scientists and mathematicians strived for greater accuracy in their measurements and calculations. From the early days of human civilization, the need to quantify and measure the world around us has driven innovation and discovery. Early mathematicians recognized the need to express numbers with an appropriate level of precision, understanding that the accuracy of their calculations could significantly impact their results. They developed various methods and tools to enhance their ability to measure and calculate with greater exactitude. However, it wasn't until the 19th century that the concept of significant figures was formally developed. This period saw a surge in scientific inquiry and technological advancement, leading to a more structured approach to measurement and data representation. Today, significant figures are an integral part of the scientific method, playing a crucial role in ensuring that our measurements and calculations are as accurate and reliable as possible. They help scientists and researchers communicate their findings with clarity and precision. By adhering to the rules of significant figures, we ensure that our understanding of the natural world is based on reliable and reproducible data. This practice is essential in fields ranging from physics and chemistry to engineering and environmental science. Significant figures serve as a testament to the ongoing human quest for knowledge and our unwavering commitment to accuracy and precision in all scientific endeavors. They remind us of the meticulous work of countless scientists and mathematicians who have contributed to our current understanding. So there you have it, a whirlwind tour of the fascinating world of significant figures. This journey through history highlights the importance of precision and accuracy in scientific work, and how these concepts have evolved over time. By mastering this essential skill, you join the ranks of scientists and engineers who strive for accuracy and precision in their pursuit of knowledge and innovation. Your ability to use significant figures correctly will enhance the quality and reliability of your work. Keep those significant figures in mind and never stop exploring the wonders of science. The quest for accuracy and precision is a never-ending journey, and your contributions are vital to the ongoing advancement of human knowledge.